Good morning, students. Once again, we are here to discuss our DOE worksheet 37, and today we will discuss about motion. It's a kind of revision for this chapter, and today we will revise whatever we did till now. Okay. See, we say that. Just wait, beta. I'll zoom it for you. Right. Okay. See. We say that an object is in motion when its position changes with respect to time. Whenever a object is in motion, its position is changes with respect to time. Whenever an object is in motion, it's characterized by are described by the help of physical quantities: distance, displacement, speed, velocity, acceleration. All these quantities describe about the characteristics of a object's motion. Right, whenever an object is in motion, it is characterized by with the help of physical quantities like distance, displacement, speed, velocity, and acceleration. Okay, so distance is the length of an actual path covered by an object. Distance is what? Distance is the actual path covered by an object. Displacement, the length, the shortest path between the initial and final position, and its unit is meter, and the unit of distance is also meter. Speed is the rate of change of position of an object in meter per second. Velocity, the speed of an object in a particular direction, is known as its velocity. Okay, see, student, this is the graph of uniform motion. This is a graph of when object is in at rest, and this is the graph of non-uniform motion. Right, what about acceleration? Acceleration, the rate of change of velocity of an object, and its unit is meter per second. And remember, have you remember about this graph? Okay, this is a graph of uniform velocity, right, where there is no acceleration or zero acceleration. Okay, so the with respect to time, the object is with the moving with the same velocity. Right, next, this is a graph of uniform. This is a graph of uniform acceleration. See, this is a slope, and velocity is increases with respect to time. So this is a graph of uniform acceleration. This is a graph of retardation. Okay, and non-uniform acceleration means retardation. This is a graph of retardation or negative acceleration, you can say, where the object becomes zero with respect to time. Okay, and next we have, this is non-uniform acceleration graph. Okay, so this is the case when you drive your car in a road, in a traffic road. Okay, so first speed is increased, then decrease, then increase, then decrease. So this is a kind of non-uniform acceleration graph. Okay, next, then we have studied about our three equation of motion. First, v is equal to ut plus v is equal to u plus at. Second, s is equal to ut plus half at square, and third is v square minus u square is equal to 2s, where u is initial velocity, v is final velocity, a is acceleration, and t is time taken. Okay, and student, this is how we get these equation of motion from by the graphical representation. So the distance covered by an object is equal to the area of the selected part of the graph between t1 to t2 of any part of the velocity time graph. Whenever we have given with velocity time graph, if we calculate the area between O, A, B, C, then we will be able to calculate all these three equation of motion. Right, next we have, okay, Gyan asks, Didi, is there any situation where the speed of an object of a motion remains constant but still accelerate? Yes. Then Didi replied, it happens when an object undergoes a uniform acceleration, okay, circular, uniform circular motion. If we move a stone tied with a thread along a circular path while being stationary at a point T, the speed may remain constant, but the distance of the motion will keep on changing constantly, and this type of motion is called as uniform circulatory motion. Okay, see, uh, exact definition of uniform circulation motion, it is the when the object is moving under a circular path, its speed remains the same, but speed may remains the constant, but direction of the motion keep on changing, and this is why this is called as uniform circular motion. Means it happens when an object undergoes uniform circular motion. If we move a stone tied with along a circular path while being stationary at a point, its speed may remain constant, okay, but the direction of the motion keep on changing, and this type of motion is called as uniform circular motion. Okay, so we have exact definition of uniform circular motion, that is when an object moves with a constant speed in the circular path, then the object its motion is called as uniform circular motion. An example, athlete moving on the circular path, and a satellite moving around the earth. And also you can take the example of this tied stone with thread, okay, and also in a circus when biker moves with the moves around the circular path. If the radius of a circle is r and t time taken to complete one revolution or one lap in t, so v is denoted by the velocity, then its velocity is equal to 2 pi r divided by t. Okay, so let's do practice exercise. First, give the difference between distance and displacement. You can easily write distance and displacement from here. Right, this is the answer of your first question. Write down the three equation of motion. So bacha, you can write these two. V is equal to u plus at, to s is equal to second, s is equal to half ut plus s is equal to ut plus half at square, and third v square minus u square is equal to 2as. Third question, give the three example of uniform circular motion. Bacha, you can write from here. All the examples you can write from here. These are the examples: athlete running on the circular path, a satellite moving around the earth, third a stone tied with a thread, right? And you can give the example of that biker also moving in the circus. Okay, next question we have. Okay, find the speed of an athlete who complete one lap of circular track with a radius of 100 meter in 1 minute. See, first of all, we have to write whatever we are given with, right? Just like we have radius 100 meter. We know the value of pi is 22 by 7. Then we have t, 1 minute, that is 60 second. Then we have v is equal to 2 pi r divided by t. Put the value of all these 2 into 22 by 7 into r divided by t. T we have 60. 0 says 0 cancel, 3 3. Then we have 220 divided by 3. If you divide this, you will get around 10.47 meter per second. So student, this is all about your today's worksheet. Hope you liked it. Hope you understand it. If you really like, share and subscribe. Thank you, beta.